In stoichiometry, you must know how to write chemical formula, how to balance chemical equations, and then calculations. At the beginning, number one, how to write chemical formula. To write chemical formula, you must know the valency. We said before that we have group and valency. Group 1, valence 1, 2, 2, 3, 3, 4, 4, 5, 3, 6, 2, 7, 1. And then 1, 2, 3 was positive. It refers to losing electrons. 5, 6, 7 was negative, refers to gaining electrons. 4 to be accepted to be positive or negative. Like for example, for calcium, 20, 2, 8, 8, 2. So it's group 2. The valency, it will be 2 positive. For Cl, 17, 287 in group 7. So the valency is equal to negative 1, to be like that. So for group and valency in the periodic table, you will find that group 1, 2, 3 is equal to the same numbers till the 4. After that, complete of 8, 5 to be 3, 6, 2, 7, 1. And then for transition metals, we said that they have more than one valency. So how can we know the valency of transition? All transition have common valency too, except silver valency 1. And if you have any number beside the transition metal, it will be its valency, like I, double I, triple I, IV, V, VI, and V double I. Refers to valency 1, 2, 3, 4, 5, 6, 7. Like, for example, for how to write the formula of iron oxide and iron trioxide. For iron oxide, and if you have iron 3 oxide. For iron, you didn't write any number besides, so it will be 2. Oxygen is 2, so the formula will be FeO. If you have the same number at the both sides, cancel each other. For iron trioxide, Fe valency, it will be 3. Oxygen is 2, so the formula is Fe2O3. So how to write the chemical formula? In the periodic table, for elements you have group and valency. For transition, if you have any number beside, it will be 2 except silver is 1. And if you have any number beside, we will write this number. After that, you must know the radicals or polyatomic ions. Polyatomic ions or radicals. We have for valence 1, ammonium NH4, hydroxide OH, nitrate NO3, nitrite NO2. This was valency 1. Ammonium, and we have a difference between ammonium and ammonia. Hydroxide, nitrate, nitrite with valency 1. For valence 2, we have carbonate and sulfate. This valence 2. For valence 3, we have phosphate. After that, you must know the difference between 8, and 8. For the difference between 8 ite, and ite in case of sulfur and nitrogen. Sulfate, it means that it will be SO4. It is sulfate, valency 2. Sulfite, SO3. Sulfide, S. Nitrates, NO3. Nitrites, NO2. Nitride, N. So for 8, it means that highest number of O. This is highest O. I'd reduce one O. I'd without O. For example, if you want to write the formula of magnesium nitrate, magnesium nitrite, magnesium nitride. How can we write the formula for each of the following? For magnesium nitrate, you will find that magnesium is group 2, nitrate valency 1, so it will be MgNO3 bracket 2. This is for magnesium nitrate. For magnesium nitrite, Mg2NO2 valence 1. So it will be MgNO2 by 2. For magnesium nitride, Mg, these two. N-ide means the element to be N, valence 3. So it will be Mg3N2. So this is magnesium nitrate, magnesium nitrite, magnesium nitrite. Okay. So try to write the chemical formula for each of the following. Iron 3 oxide, ammonium carbonate, calcium phosphate, magnesium nitride, aluminium sulfite, sodium nitrite, copper 1 oxide, zinc sulfide. So in this case, we said that iron 3 oxide, it will be iron Fe3, this is the valence of iron, and oxygen is 2, it will be Fe2O3. Ammonium carbonate, ammonium is 1, carbonate is 2, so the formula it will be NH4 by 2 CO3. Calcium phosphate, calcium 2, phosphate is 3, it will be CS3PO4 bracket 2. After that, magnesium nitride, magnesium is 2, nitride, it means N, so it will be Mg3N2. Aluminium sulfide, aluminium is 3, sulfide SO3 is 2, so it will be Al2SO3 by 3. Sodium nitride, sodium is 1, nitride NO2 is 1, so it will be NaNO2. For copper 1 oxide, copper here is 1, and then oxygen is 2, it will be Cu2O. If I am telling copper oxide only without written I, so it will be CuO. Zinc sulfide, zinc is 2. This transition without any number beside, so it will be 2. Sulfur is 2, so it will be this sulfide, the element, so it will be ZnS. After that, how to balance chemical equations. For balancing equation, you must know before how many atoms in the molecule. For example, if I have 2CaNO3 by 2, and then I am telling you how many calcium atoms and how many nitrogen atoms and how many oxygen atoms inside this molecule. So in this case, you will find that the 2 is common factor for all the compound, and then 2 is common factor, the elements inside the brackets, and 3 for all only. So for calcium, we have only 2. For nitrogen, we have 2 multiplied by 2 to be 4. For oxygen, 3 multiplied by 2 multiplied by 2 to be 12. After that, how can we balance the chemical equations? For example, if you have C2H5OH plus O2 gives CO2 plus H2O. At the beginning, you must know that the total number of atoms in reactants equal total number of atoms in products. And also you must know that if you have odd and even, try to make both even. And if you have two different numbers, try to take the common factor. After that, for the elements repeated, make it at the last. So again, the rules for balancing equations: total number of atoms at both sides must be equal. This is number one. Number two, take the common factor for numbers at both sides. Number three, the repeated elements make it at the end. What's meant by that? For example, if you want to balance C2H5OH plus O2 gives CO2 plus H2O. So we have O, 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 make it at the end, this repeated element. And then total number of atoms and reactants equal total number of atoms in products. For example, we have C2, this is the carbon inside in reactants, so we must have 2. For hydrogen, we have 5 plus 1 is 6, so you must have 3. So total of atoms in reactants equal total of atoms in products. After that, take the common factor for the number at both sides. For oxygen, now we have 4 oxygen, and the other side we have, and here is 3 oxygen, this 4 and this 3, so the total is 7O. The other side we have 1, it must be plus 6, so we will make here 3. Again, C2 I put 2, H6 to make 3, multiplied by 2 to be 6. After that, for the number of O we have, at the beginning we started from left to right to balance hydrogen and carbon. After that, for balancing oxygen, we take from right to the left. So C2 we put 2, H6 we put 3. After that, from right to left, 4O and 3O, the total is 7. We have this 1, so remaining 6. 3 multiplied by 2 to be 6. So after that, C2 to C, 6H, we have 6H, 7, 6 plus 1, 7O, 7O. So how we balance the chemical equations? Number one, NaNO3 by the effect of heat form NaNO2 plus O2. Number 2, Fe2O3 plus CO gives Fe plus CO2. Number 3, CaNO3 by 2 gives CaO plus NO2 plus O2. Number 4, NaCl plus AgNO3 gives NaNO3 plus AgCl. Try to make them now. So in NaNO3 gives NaNO2 plus O2. We said that we have Na, N is N, O is 3, O is 4. So we will make odd even to be 2. So here is 2, 2Na, 2Na, 2N, 2N, and 6O, 4 plus 2. In the other one, Fe2O3 plus CO gives the Fe plus CO2. Fe2 will make 2, C, we have C, and then O3, and here O2. So for that, here we have 3 and 1 is 4, and here is 2, we'll put 2, but here is C, and here is C. So it will be not balanced. We'll add 1 to be 3, 3C, 3C. And O, 3 plus 3, 6, 3 multiplied by 2 equals 6. For the third one, CaNO3 by 2 gives CaO plus NO2 plus O2. For the as beginning, Ca, N is 2, we put 2, 6O, we have 4, 1, and 2, 7. So we'll make odd even to be 2. So 2, N is 4, it will be 4. O equal 12, 2 multiplied 3 multiplied by 2 to be 12. So it will be here 12, 8 plus 2 plus 2. For the last one, NaCl plus AgNO3 gives NaNO3 plus AgCl. You will find that it will be balanced.